Alright, so I'm going to do day 5, but I know I'm late. I've been catching up today. This is the third advent code I'm doing. Let's just jump straight into day 5. So, cafeteria. As the forklifts break through the walls, the elves are delighted to discover that there was a cafeteria on the other side after all. Okay, yeah. You can hear a commotion coming from the kitchen. At this rate, we won't have any time left. Sorry, just opening them. Any time left to put the wreaths up in the dining hall. If only we hadn't switched to the new inventory management system right before Christmas, another elf exclaims. You ask, what's going on? The elves in the kitchen explain the situation. Because of their complicated new inventory management system, they can't figure out which of the their ingredients are fresh, which are spoiled. When you ask how it works, they give you a copy of their database, your puzzle input. The database operates on ingredient IDs. It consists of a list of fresh ingredient ID ranges, a blank line, and the list of available ingredient IDs. Okay, fresh ingredient ID ranges, so similar to day 1, I think it was. And then available ingredient IDs. Okay, let's see what this means. The fresh ID ranges are inclusive, so 3 to 5 means 3, 4, and 5. They're all fresh. The ranges can also overlap. Okay. The elves are trying to determine which of the available ingredient IDs are fresh. In this example, this is done as following. The elves are trying to determine which of the available ingredient IDs are fresh. Okay, well, okay, that seems fine for a small input. We can create like a range. We can check that a number's in the range. I think that's fine. Ingredient ID 1 is spoiled because it does not fall into any range. 5 is fresh because it falls into that range. Ingredient ID 8 is spoiled. Ingredient ID 11 is fresh because it falls into the range. Ingredient ID 17 is fresh, falls into that range as well as the other one. Ingredient 32 is spoiled. So 3 are fresh. Okay, this doesn't look too bad, which is making me sweat a little bit. So we're going to do it in Ocaml again. Ocaml making another appearance from day 3. Actually, I'm going to copy over this stuff here. It's going to be repeated code for reading the lines. And I'm going to once again do that. I'm going to have a let's solve lines equals 0, 0. Let's do some more new lines there. What are you confused about? Okay, cool. And we're good. So first things first, let's split this down into here. So basically we're going to, in the lines that we get, which is the inputs, we're going to have to find the index. I kind of would really like move, associate, singleton, fold, right, left, this, append, combine, compare, concat, drop while equals, exists. You know, all this stuff. We need to basically I want to now find the returns the list element that satisfies the predicate. So it takes in a function. Like this. Isn't there like find something else? Okay. Not found. Okay, raises. So int option. Yep. Let's what do we call this? Split like split index. Is there a way to assert? Ocaml assert option is sum. Assertion fail. Okay. Maybe we can do this. Assert option dot is sum. Is sum. Okay. Ocaml unwrap option. Yeah, that's kind of what I want to do. Option.get sum. Let's just go like get sum, which is like op match op with sum I, return I, otherwise none, fail with needs to be there. I thought find index actually returns. So now we go and pipe this into get sum. Okay. Dot partition returns a pair of lists where L1 is a... Oh wait, hold on. Maybe we just want partition. Returns a pair of lists L1, L2, where L1 is the first of all the elements of L that satisfy the predicate F, and L2 is the list of all the elements of L that do not satisfy F. Oh, actually, well, maybe we don't have to do it this way. We just find a dash. Yeah, let's do it. Let's just do it this way. Like, let's actually let's go filtered no empty lines equals list dot filter fun items are not equal to new line of lines. I where I string dot includes dot contains I and then the char of dash ranges items ingredient scope items, and this takes in no empty new lines. Ranges. Let's just go just like a sanity check. Don't need that. 4 and 1, 2, 3, 4, 5, 6. Oh. Let's actually go maybe string dot length of I bigger than 1. Bigger than 0. Yeah, because it will be an empty string. Yeah, not a new line. Okay, perfect. Okay. Good. So now we have that. So it's funny how, you know, like writing things in a language like this. I wonder... No, we can't, like... I wonder if we could, like, one-line this stuff, but... Anyways, I was saying, writing things in a language that you're not comfortable with, and especially a language that is so different from like imperative languages, such as Ocaml, makes your brain think differently and in different ways, which I think is one of the reasons why I love Ocaml so much, at least for writing like toy programs like this, because it forces me to think differently. And yeah, it's also just a joy to write. Like, it's really fun. So that might be a bit boring for people to watch because it's hard. Like, I find it hard to write, so you might find it hard to read as well. But either way, let's keep going. So all we have to do, really, is construct valid ranges and go through them. Yeah. Let's construct get range from str equals let's a and b equals string that's split on char. This is going to be, the char is going to be a dash, the string is going to be like lower, higher. Oh, after it's split, actually let's pump it into int of string. List. Do we need this to be like this? No. Split on char. This string. What's wrong with you? Ah, there we go. Okay. Let lower equals list.nth. Lower, upper. And let's actually go like if list.length list bigger not equal to, then fell with list must be exactly 2. Okay, it's like an assert. Actually, we can do that with the built-in. No? Okay. Yeah, we can assert it like this. Okay, we just, that's it. We return lower, upper. And not even no return. Get range. That's it. Let's ranges. I think I can shadow. Equals list.map get range with ranges. Yeah, so we can shadow, which is another based, very, very based thing. Exception failed. Assert failed. Ooh. Why? Two. Oh, assert it is equal to this. Perfect. Okay, good. And now all we have to do is go through the items. And we go for each range. Actually, for this, let's here's item in ranges. Ranges, item. So we go basically like we create another function is item in range I, which is list dot, which basically returns for upper equals return I is bigger than or equal to, or lower, smaller than or equal to I, and I smaller than or equal to upper, because that's how our range works. And here we basically just go list.sum .any list.sum okay, basically I want like list oh, I need to it's like a good AI question actually. Let's go in is there something in Ocaml? Ah, no, let's not ask AI anything. I want to keep in the spirit of this. Let's just create it. List some L fn, which is going to be a boolean, which is going to be like match L with, we return false. If fnl, then true, else list some tail fn. I don't really know this, like, this should work. I don't really know why it doesn't work. So look, day 3, we had something like this. Oh, because it that has to be marked as recursive. And we don't need this. It's just applied. Some ranges. And the predicate basically takes in is item in range. Hold on. It's not L. It's actually going to be head. Yeah. Function item by item where is item in range. Ah, I can pass in is item in range, and because that will be then curried, right? This takes in is item in range, returns this. For example, if I leave it like this, this takes in list item, either returns boolean and boolean. Ranges is item in range. And partially applied with I. There we go. Partially apply that with I, and then that carries into the other one. So now we just take in a list of ranges, an item, and boolean, and now, oh, that's gorgeous code. Look at this. I love that. Let one fold left on accumulated I. If this item in ranges I, then accumulated plus 1, else ACC 0 ranges. The value as right, yep. The special respective type int. Oh, items. Hold on. Item, that items equals list dot map int string items in. There we go. So part 1 says it's 3. I need to get rid of this throwing me off. 3 items, which I think was correct, wasn't it? Six of 1. Very nice. That was quick. Felt like I sped through that. But part 2 is... Oh, I'm scared to read. The elves start bringing their spoiled inventory to the trash chute at the back of the kitchen so that they can stop bugging you when they get new inventory. The elves would like to know all of the IDs that the fresh ingredient ID ranges consider to be fresh. Now the second section of the database, the available ingredient IDs, is irrelevant. Yep. What does this mean? Like, the ingredient IDs that these ranges consider to be fresh, 3, 4, 5. So as an example, the fresh ingredient ID range consists of a total of 14. What? That's easy. 5 minus 3 plus 1. Is that all? No, surely. That sounds... So like we got a range. Oh, wait. Okay. No, I mean, it was looking good. 20. Okay, so I'm a bit off. Oh, because there's duplicates. Yeah, I forgot there's duplicates, right? Oh, yeah, it's a space problem then. There's duplicates. Ah, I see the problem. Okay, well it wasn't, yeah, of course, yeah, the overlapping ranges is the problem here. Otherwise this would be like very, very easy. Well, what we have to do is make it so the ranges don't overlap. So let's think about this. So let's say you have range 3 to 5 and then the range 4 to 10. You could find overlaps. If we have overlaps, we can merge the two. So let's say we have this, and they do overlap. So we merge the two. So actually, what we're going to do is we're going to get a big list. We're going to find if this first one overlaps with any of the others. If it does, we remove 2. It's interesting. So if I have this, I then want to do like, actually we remove both of those and we go 3, 10. Right, that removes the overlap, and then I can keep part 2 like this. If we have more, let's say like basically like, I don't know, 6 to 7. Huh. Funny number. Then I think we still like, we take it slow, like we go through the list until no mergers happen. Yeah. Okay, so I'm gonna start writing. I have some thoughts. Let's go like let non-overlapping ranges takes in ranges and is gonna return ranges. So let's create an accumulator and ranges. Now, we're gonna start by going through the first item, right? We'll go through the first item, check if it overlaps with any, and if not, we put it onto the accumulator. If it does, we remove both. So basically we want to compare the nth item. Yeah. So range is going to be lower, upper. And then we check basically like, does it overlap? Yeah, I have, yeah, okay. So basically we're gonna split the list and we're gonna check, does it overlap? And then we do this until nothing happens. If that makes sense, right? So we have this first range. Okay, so we need to go through ranges. Through each range, does it overlap? And then, but if it doesn't, oh, it's actually, I'm finding it difficult to express this in like a functional way. Let's say we have like 12, 20 here. One pass of the list, I would expect to just go take this one. Actually, like, I want to make sure that this here is clean, nothing overlaps, and then take the second part. Yeah. But I am kind of struggling now because, okay, so we do this once. Let's say, okay, this is like kind of our outside one, the one we're checking against, making sure there's overlaps. Okay, we do get overlaps, so we go, okay, so that's going to be 3 to 10, 6 to 7, 12 to 20. And then we continue. It's going to be 3 to 10, like there's no actual overlap, and 12 to 20. And then nothing would happen after. So we know that 3 to 10 is completely unique. So we put that on our thing. Yes, okay, so there's a few steps here. So basically I'm gonna do the first one. Like check that it overlaps with 1. Okay. And then return everything. Let's create a let do is overlapping, which is up one, sorry, lower one. And to check that they are overlapping is to basically say that let's take 3 and 10, 4 and 10. Let's say that why am I drawing a blank? Can I get the lowest of the two? 3 and 4, 4. 3 and 4, 3. Equals Let's put it up there. Lower 1 is less than mate, I am struggling. I need paper. I'm like, I cannot visualize that. I can't like figure that out properly. 3 to 10, 3 to 5. I need to like draw this on paper or something. 3, 5, 4, 10. How do we figure out that you are overlapping? We've checked that the highest of one is bigger. Yeah, so one of them, I'm going to do the first like predicate thing. So lower 1 is less than lower 2, and upper 1 and, no, sorry, lower 2 is less than upper 2. So basically, for our example there, this would be 3 is less than 4, and 4 is less than 1, actually. 5. Does this fully mean that it's overlapping? Or the other way around, you know? Okay. Get combined ranges on upper 2, upper 1, lower 2, upper 2 equals min of, let's min equals min, so lower equals minimum of lower 1, lower 2. What I'm gonna do, okay, does this overlapping logic make sense? So if it was the other way around, like this was, so we were doing, let me think of another example. We have 10 to 12, and then we have 9 to 13, so actually fully encompassed. So the lower 1 is 10, lower 2 is 9, so no, it wouldn't happen there. Lower 2, 9 is less than lower 1, 10, and lower 1 should be 9 is less than upper 2, 12. Yeah, this would work, I think. Same time, kind of do just want to get on with it. So, okay. That was the first part. So, let overlapping index equals list.sum dot find the index item where Okay, hold on. Recursive loop, CC. Head, tail, here we go. If we say, the current range that we're picking, oh no, hold on. Yeah, so we have head here, and we want to match head against any of the tail. And when we combine them, we put them onto the ACC. It's actually getting weirdly complicated. Let's get this here, overlapping index with I, where actually this is overlapping. Fn partially apply is overlapping head. Okay. If the head is overlapping with anything, okay, so there we go. If match overlapping index with sum, here we actually go call loop. Get combined ranges of heads and list.nth at overlapping index and find list of overlapping head. Find. Oh, this needs to be applied for tail. Okay, and then none. We're actually going to loop with heads. And R. Okay, there we go. Now it's working. So otherwise, if we don't find a combined range like an overlapping, we can just add heads onto the ACC, continue on with tail, in loop this ranges. Maybe? I'm a little bit scared of what I just write, to be honest. Let's non-overlap ranges equals list dot $28. No. I think I just write some abysmal code here. Okay. Basically, if there is an overlapping index, then find index of something that overlaps with the tail. And then overlap of fan is the head is overlapping. Okay. We go tail, and then we go into here. If there is some, then actually we combine those two. We add them to the ACC, and then we continue with the tail until we're fully combined. But then we're actually, yeah, ranges here. Okay. We need some things here. So equals match Upper, and then we go loop the tail. Actually, this can just be this. That can be that. This can be that. This can just be print ranges. (12 to 18, 12 to, okay, well that's obviously wrong. What if instead of tail, we just do this, just to debug, see what's going on. 3.5, 3.5. To be fair, it doesn't overlap with anything, does it? Let's get rid of 3.5. Upper 10 to 18. That's good. I think it just needs to go on for longer. Yeah, I think it, like, it's close, to be honest. But it just needs to go until there is no changes. Maybe I can do this here. Changes. And here we go true. I think there's a much nicer way of doing this, but let's go work. Let's go. And then we go like non-overlapping ranges equals this, and we go. We go until basically, like, I want to loop. If non-overlapping ranges, VCC. Actually, just this. If changes, then here I can put that in. Oh, wait, no. Print printf. True, true, false. Oh, but it's still giving me these things. When we do combine them, the combined ranges, the head, this together with the ACC. Maybe is this not a is this maybe a precedence issue? No, it wasn't. There were changes, but then it didn't remove. You're not removing the ones that are, you know, bad. Let's move this up here. Let's do print ranges. Ranges. Okay. 12, 18, 12, 20, 10, 18. And then it changes to 10, 18, but doesn't remove 10, 18. The other one. 10 to 18. Which is, you know, like it is a combination, but like get combined ranges seems to be like doing way too much, adding too much stuff. And this, yeah, then we add that to the accumulator, and we do the tail. Oh, but tail needs to be removed. Ah, I see. Let's tail out index list dot remove Ocaml remove item from list. I actually did write something similar to this. Slice at index. Oh, not quite though. Oh, wait, no, let's filter. We just filter, yeah. Where? Let range equals list of nth on the tail of R, and then we can even do the range there. Hold on. Yeah, okay, because we're combining. Change around range, and we go list of filter, and we filter the tail where upper, lower, up, oh, like, let's go L upper, go to U, and upper, not that, and up, that's lower, and upper is equal to U. What? Wait, why is that the nth tail? What? No. Why? Wait, why does it think it's this? That's kind of weird. Oh, there's an and there. That's, was that why? Just says weak. We have the predicate, we have the list, we have this. Oh, it can't seem to figure it out. Which means I've done something wrong, because it's usually really good at figuring stuff out, so.